Hey everyone, so in this video we are going to look at how to cycle through different enemies. So right now, whenever the battle starts, it's always this enemy. So what we're going to do in this video, we're going to add a second enemy, and then we're going to demonstrate how you can randomly choose which enemy will be spawned. So to do that, we need to turn this into a prefab. But before we do that, let's give it a tag. So we're going to click on tag, going to do add tag, and we're going to call this slime. Going to save it. And then we click back on slime. Remember, adding the tag just creates the tag. It doesn't actually apply the tag. Okay, now we've applied the tag. Now let's take the slime and put it into the scene. Okay, now what we're going to do, we're now going to create a new animated enemy. So let's delete the slime. And now we're going to, let's do the same process from the first video. So we're just going to take one of the images, put it into the scene. That way it automatically creates an object with a sprite renderer. We said we want the order and layer to be 1 for the enemies. We go to animation, make sure it's the right one, create, and we said we're going to have a naming convention. So idle, since this is the idle animation, and this will be ghost. And then similarly, we take those ghost frames and we just drag and drop them into the scene. Again, if you click down here, it expands out. Now here, much clearer. You can definitely see these more visible. The other ones were kind of translucent for some reason. So let's set this at like, I guess 18 frames per second. It's purely arbitrary. I didn't plan it out when I drew it. I just wanted a few frames so I could have an animation sequence. And just like the blob, it's kind of like bobbing up and down. So this is it going up, so we want it to come back down. So just take those same frames and just put them here in sequence. Now, if you have an animation that automatically cycles, you don't have to do this. This is just because I'm saving frames. So rather than redrawing them, it can just bob up and down. All right, so let's change this just to ghost. And now since we're familiar with the process, let's jump right into creating the attack. So it will be E underscore attack, ATT underscore ghost. And again, we take our frames, drop them into the scene, change the frame rate. I'm going to go with 18 again. And again, this is a cycle that goes out and then comes back. So we'll just put these back here. Okay, so what we're going to do now, let's just run it to see that it is animated. There you go. Kind of quick, actually. Like you said, too much caffeine or something. Let's just tweak that. So we have idle ghost here. We'll just change this to, say, like 12 frames, make it a little bit more floaty. That's fine. Okay, so now we have our animation. We have the idle animation. We have the attack animation, but the attack animation doesn't play. If you recall correctly, that is controlled by enemy con. So we're going to click on ghost, and we're going to drag and drop enemy con. We're going to open that up. And here's an example where we're going to have to change some of our code again. Right now, this is a constant. This is saying always play this animation. But since we're using the same script for multiple enemies, we can't use this name, this constant. We need to have this change based on what enemy this is attached to. So this is saying E attack slime, okay, enemy attack slime. this now needs to be E attack ghost. So how do we do that? We're going to replace this with a variable. So right up here, and this shouldn't have to be static. I don't think anything else is going to need to know this variable, have access to it. So private, and this is going to be string. This is just going to be letters and numbers. So private string, and it will be called enemy ATT. Don't think I'm using that in this script. Don't believe so. So enemy attack. Actually, I guess we can call it enemy attack name. So it's a little bit more descriptive of what we're doing. And we're going to take this. Actually, leave it as enemy attack name. In the start section is when we're going to apply this based on the tag. So we added a tag to the slime. So if GameObject dot tag equals, and we use slime, then enemy attack name will be this. We have now, and this gets replaced with the variable. We have now successfully replaced this with a variable. So rather than being a constant that can only choose one animation, it's a variable. Sky's the limit now. Now we need to rinse and repeat. So you're just checking the name, the tag. So you're just checking the tag, the value of the tag that's attached to the object the script is attached to. And based on that tag, you're choosing what this should be. And then it gets played there. Let's add our semicolons. Now we're going to have to do the same thing here because it's not always going to be idle. So private string enemy idle name. And even though it doesn't get played down here, you can still assign it here. Why have to check the tag multiple times? So enemy, I just cannot type in this series. So enemy idle name equals idle underscore slime, idle underscore slime, enemy idle name, idle underscore ghost. And once again, we take a constant and replace it with a variable. Enemy idle name. So the only thing missing at the moment, we have not attached a tag to the new ghost. I don't believe. Nope, we have not. So tag, add tag, ghost, save, click on it again, apply it. So now the script should be able to differentiate between enemies. So let's go ahead and add the animation event. So with the ghost selected, we go to animation and we go to E attack. And just as we did with the last one, we need, I say the last one, the slime enemy. we are going to put the marker here. We click on the plus sign here to add an event. We click on that event, and the function's already there because we're reusing it now. So now let's look at that. So this is where we were, and we're saying that the turn changes the player. Here's how much damage you get received, so that we really should replace with a variable now because each enemy is going to do a different amount of damage. And yep, so let's do that. So let's do, and again, for the time being, I believe this one can be non-static. So private float enemy dim, and we don't give it a value. And again, based on the tag, we're going to define it in here. It'd be nice if I could spell. My goodness. So enemy dim. So enemy dim for the slime will be, we said 10. And enemy dim for the ghost we'll say is 20, just so we know for a fact the numbers, want the numbers to be substantially different enough. Okay, if I have not forgotten anything, that should do it. Actually, there's one more thing. So I put in these variables, but I did not actually apply it here. So enemy dim. Okay, so if I haven't forgotten anything, what will happen? The ghost is on the screen to begin with, so we're not randomizing yet. I want to make sure the ghost is functioning before we go to randomization. So let's go ahead and give this a whirl. So he's idle. He should do 20 points of damage to us. And he did. So just like that, you have added a new enemy. So now the randomization is easy. We just take the ghost, we drag and drop that into asset area, turning it into a prefab. We delete it from the scene, and now we just need the game flow script to run a randomization and determine, based on that randomization, which object gets spawned. So if we go to game flow, let's just add, this probably doesn't have to be static, but we'll be consistent with these. So public static, and we'll have this be an int, and it will be which enemy in no default value, so it'll be set to like blank. So in the start section, we're going to have which enemy is equal to random dot range, and it'll be 1, 3. Now, the way that random range works for integers, this number is inclusive, which means it could choose a 1, but this number is not inclusive. Why? Because it's unity. So that means the only numbers that would be selected are 1 and 2. So we have 2 enemies, so we need to have a range of 2. Based on this, we'll determine which object is instantiated. You can either use select case, or you can use if statements. We'll use if statements since we're familiar with those. So what we need to do, we now need to create linkages and references to those prefabs. So public transform ghost enemy. Public transform slime enemy. If which enemy equals 1, our good old friend, the instantiate command. So again, to instantiate something, 3 arguments: what is being instantiated, where it's being instantiated, and the rotation of its instantiation. So we are going to instantiate ghost enemy. We're going to use the ghost enemy's position and the ghost enemy's rotation. That is the position and the rotation of the prefab. And now just rinse and repeat. So now that you've seen how to do 2 enemies, you can do 5, 10, 100. This is just the same thing over and over again. You just create a reference for the new enemy, you increase this number, and then you have it be instantiated. So in this one, though, it would be slime enemy. Slime enemy. Slime enemy. And now, if we go to our GM object, there's the references. So our ghost enemy needs to be ghost, and our slime enemy needs to be slime. And if I haven't forgotten anything, that should now do the randomization. Slime. There we go. So with only 2 enemies, you're going to find anomalies like that. So 3 out of 4 times it was the slime. And we'll just fight this out. So we attack it. It does indeed do 20 points of damage, but that's to be expected. Okay, so now you have enemy randomization. And the last thing for this particular video, let's add MP. That way the player can only use the skills just so many times. So that's pretty easy. Some of this functionality we've already looked at. So for instance, we already have our hero text, okay? So let's take a quick look at the script attached to that to see if we can repurpose this for MP. Yeah, we should be able to, because we'll just say if the name is, say, hero MP text, then it's going to be a new MP variable. Yep, so we should be able to repurpose that. So let's copy that. Move it down. And we'll change this to MP. But again, this doesn't matter because we overwrite this with the script anyways. Now let's go back to our script. And we just copy this. Again, part laziness, partly to reinforce that it's not new functionality. You're just repurposing the code. So this we need to create. We don't have a hero MP yet. So we go to game flow. Now, when I'm writing a game, the tendency may be, okay, well, let's keep all similar variables together. Here's the problem. If you break something, you might not know what you broke. So what I try to do is if I add a new variable, I actually don't collect it by type. I just do this sequentially. That way, if I broke something, it might help me backtrack to say, well, this was the newest thing that I added. Did that break it? You can do whatever you want. The actual sequence does not matter. The sequence of the variables here. So public static float, and it's going to be hero MP in, whoops. And we'll set that to say 50. And I'm sure you can see this coming a mile away, that if we have hero MP, we also need max hero MP, because if you can do something like drink a potion or whatever that restores MP, then public static float hero, max, let's keep the naming convention consistent, hero MP, and that's also 50. So again, it's like you created a structure and now you're just repeating it. So hero MP, max hero MP, we go back to our text, and this should be hero MP. Let's test that first, and then we'll start changing the value and making decisions based upon that value. So it should say MP and it should say 50. And it does. So now we have to make decisions based on that value. So displaying it's one thing, using it for decisions is separate. So right now, icons are where the spells are cast. So right now, if you click on one of those icons, it simply instantiates the spell and everything works. Now what we want to do, we want to check to see if there's sufficient MP to do that. So sword will say does not take any MP, but we'll say that everything else does. Fire, heal, and poison. So a few ways you can do this, but you can just add another condition here. So you add another parenthesis, double ampersand, another parenthesis, and game flow, because again we have to say where the variable is declared. Game flow dot hero MP is greater than 10. Let's say it costs 10. Another parenthesis. Why? Everything you check, every condition has to be surrounded by parentheses. And then the whole thing has to be surrounded by parentheses. Okay, so what this is saying is that fire will only be cast now if there's at least 10, if there's greater than 10 MP. So actually, let's make that greater than 9. We'll say it costs 10. Which means that when we instantiate the spell, we need to subtract the amount of spent MP. So we'll say game flow dot hero MP minus equals 10. And let's run it there. And if that works, again, it's just rinse and repeat. It's just adding this to the heal, adding this to the poison, adjusting the number as far as how much it costs. Does maybe heal cost more? That's all game balance. So functionally, it's the same thing. You just need to determine how much each ability should cost. So we apply that to the fire spell only. So we're going to click on fire. Sure enough, it costs 10. Click on fire. 10. Fire. 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 And now clicking on it does absolutely nothing. So just like that, you've added the beginnings of an MP system. But if all are working correctly, I should still be able to attack. Indeed. So let's just expand that out. So maybe heal only costs 5. So again, you're checking for the a minimum value for the hero MP, and then you're going to subtract out the cost. And again, each condition needs to be surrounded by parentheses, and then the whole thing has to be surrounded by another set of parentheses. And let's make this cost even more because it is poison. So that would give us, like, maybe this is the kind of calculation you do. Since we have 50 MP, that gives us 3 poisons and a heal. So when you're coming up with the amount of MP and the amount of cost, keep that in mind. What's the overall kind of arsenal that it gives them of spells? So if we do a poison, this should go down to 35. If we do another poison, it goes on to 20. 5, then I shouldn't be able to poison. I shouldn't be able to fire, but I should be able to heal. And can't heal again. So there you go. So it took you just a few minutes to create an MP system and to have minimums required for each spell, and that using those abilities, those spells, does indeed consume MP. So let's build out the unique attributes of the enemies before we wrap up this video. So let's go back to our enemy script. So we already gave unique animations and a unique amount of damage, but let's also change their HP and let's start working on resistances. So for the slime, we'll say that game flow, because that's where we have the enemy HP, dot enemy HP is equal to 80. And here for the ghost, we'll say game flow dot enemy HP is equal to 90, just to make sure that we are indeed overwriting the value we declared in game flow. We declared 75 over there. So that gives them HP. So actually, let's run that. There we go, 90 for the ghost, 80 for the slime. And if you go to game flow, you can see we had originally set it to 75. We could just blank that out now if we wanted to. I think we will. So let's add a new variable for reduction to physical damage. So public static float enemy PHY for physical, RES for resistance, and we'll set it at, say, 5. Actually, let's not set it. We're going to overwrite it anyways, just like we're going to overwrite that, so we don't need to give it an initial value. So we go back to enemy, and it's game flow dot enemy physical resistance, and for the slime, it'll be 0. We'll say it has no physical resistance. Game flow dot enemy physical resistance is equal to 5. Now these had to be static, that way it's accessible to the script where we actually do the enemy damage calculation. So that's done in self-destroy. So self-destroy is where we actually apply the damage to the enemy. So this one is the sword. This one is fire, and then this one was poison. So you just have to make sure that you keep it straight. So right now, this is saying reduce it by this amount. But if we modify this and we say minus game flow dot enemy physical resistance, since this is declared for each and every enemy, if it's 0, then they get the full 15 damage. But if it's a positive number, then this gets reduced. You just have to make sure that this, using this approach, you don't want this to ever be greater than that, unless you want the enemy to be healed by something, which you could. Like sometimes an enemy is so strong to say an element, they actually get healed if you attack by it. So what should now happen is the slime should take 15, the ghost should only take 10. So let's run this. So here's the slime. If we do this, he should take 15 damage. He did. There's the ghost. He should only take 10. He did. So again, that quickly you've now added the beginnings of a resistance system. And then it's just building out the different variables as far as resistance to fire, resistance to physical. Do certain things actually heal it? And in your final version, you'll probably actually do a calculation here as far as, well, it's a calculation, but you'd probably actually use multiplication. That way it scales, okay? So right now you're just doing an absolute subtraction. You're saying take this amount and reduce it by a certain amount. So you're probably actually going to want to multiply it. So rather than reducing it by 5, you actually might want to reduce it by 30%, that kind of thing. I just don't want to get into that right now because then you have to start working with rounding and things like that, and I really don't want to get into those math calculations. I really just want to show you the basics of how you create a resistance system. Okay, so I think that's probably a good place to end this video. And if there's any requests, just let me know. I haven't seen any yet. So I'm thinking there might be just one more video because now you have randomized enemies, multiple enemies. You've created the resistance, strengths, and weaknesses for the enemies. About the only thing that's common that this is missing would be to have multiple enemies on the screen at one time. Don't know if I really want to do that in this project. And the other thing there are no sound effects, but for sound effects, I'm really going to have to go get some public domain sound effects because I don't have any software to create sound effects. So if there's anything you want to see, just let me know. I hope that you have found this to be useful, and please enjoy the rest of your day.